Okay, so next speaker, yep, there he is, Lakshantha. If you're ready, you might want to share your screen with us as well. But I'll bring that in, and shall introduce our next speaker. So our next speaker is Lakshantha Dissanayake. I got his first name right when I spoke to him yesterday. I didn't ask him about his surname, but he's at Siege Studio. He's going to be talking to us about Node-RED, no-code AI vision at the edge with Node-RED. So let's bring him on. Hey, Lakshantha, how are you?
Hello, Sam. How are you? I'm good.
Good. Cool. Okay, so we're a little bit ahead of schedule, but that's fine. So you can feel free to take a few more minutes longer if you want to. I shall bring your slides up and over to you.
Okay. So, can I start now?
Yeah. Go ahead.
Okay. So, hello everyone. Welcome to this talk about no-code AI vision at the edge with Node-RED. So, I'm Lakshantha, and I'm an application engineer at Siege Studio. So, my main areas of focus are IoT, embedded systems, and AI. And I have also worked in the industry for about 4 years now. So, I worked as a Udemy instructor in the past as well. So if you want to connect with me, you can check my LinkedIn, Twitter, and also check my works on GitHub. So I will briefly explain. I will give a brief introduction about Siege Studio at first. So Siege Studio is an open source hardware manufacturer which focuses mainly on manufacturing from sensors to microcontrollers to single board computers. So we also manufacture AI, IoT-enabled devices, and also industrial-grade sensors. We started in 2008, and so far we have manufactured more than 2,095 modules and served more than 350,000 users. Also, through our agile manufacturing services, you can go from a prototype to mass production in a very little time. We also have strategic partners in the industry, and we have around 200 more than 200 partners that we partner and build solutions together. So these are some of the sensors that we manufacture. So we manufacture sensors such as soil moisture, temperature, humidity, different sensors to measure the environmental conditions, and also communication devices such as the Wi-Fi, Bluetooth, cellular, and LoRa devices. Also, we manufacture main boards such as the microcontrollers, single board computers, and x86 boards. So for all these boards, we manufacture enclosures as well, which suits for industrial scenarios and to withstand harsh environmental conditions. So if you want to learn more about Siege Studio, you can visit seed.cc, or you can go to seedstudio.com to explore all the products that we offer. So moving on to the topic today. So our main topic is about no-code AI vision at the edge, right? So what is this no-code? So recently, a lot of companies are moving to no-code platforms where you don't need to write a single line of code to develop applications. So you can simply use a graphical user interface to create and build applications, just like that. So it's very easy to use for everyone. It's very easy to get started with these no-code platforms, and it's easy for businesses as well to get started, like to push solutions, because they don't need to rely on engineering, like a lot of engineering resources to build these solutions. And it's also cost effective because you don't need to rely on many resources. And if you want to customize these no code solutions, so for example, like this Wix is one example for a no code solution, like for building a website. So you don't need to have like really deep understanding about the web technologies. You can directly use a solution like Wix to build websites. So by looking at this diagram, we can see that there are a lot of companies now moving on to no-code platforms. So we can see that it's kind of becoming a future of software development. So when we talk about AI, so it's some people think that it's very hard to get into AI. So they think that you need to learn a lot of you need to have a lot of knowledge to even step foot into learning about AI. But if you build solutions like no code solutions for AI, it can really break the barrier into getting into AI. So, for example, this is the tool that I'm going to talk about in this talk. So, as you can see, this is the Node-RED flow editor, and I have just dragged a couple of Node-RED blocks, and these are the drops blocks we have developed. And using these blocks, we can directly get a video stream, and then perform object detection on the video stream, just like that, by dragging on these blocks. So as we can see, it's very easy to build these kind of no code AI solutions, and you don't need to have much effort into making these kind of solutions. So talking about AI at the edge, because our talk now we talked about no code AI, and I will talk a little bit about AI at the edge also. So when we talk about traditional computing, normally IoT devices, they need to process the information on a data center, so they are connected between a network. So but in edge computing, there's an edge device behind the network where all the data processing happens locally. So because of this, this AI running at the edge, you can have a better data security and privacy, because you're not sending this data to the cloud for processing purposes. And also you can have low latency with real-time analytics when performing AI at the edge. Also, you can reduce the internet bandwidth, because you're not sending data back and forth, as I mentioned. And also when we use cloud computing for something like to process AI, so it comes with a big cost. So you need to pay for like on a subscription basis, or like a very huge amount of money to have these services. But if you run AI at the edge, so you can reduce these cloud costs as well. And also this when running everything at the edge means you can guarantee a 24/7 reliable operation. So just in case if something wrong happens at the edge, you can quickly get into that problem and solve it right there, rather than relying on the data providers, the cloud providers, to solve the problem for you. So because of these reasons, it's very effective to run AI at the edge. So when looking at the evolution of edge AI devices by form factor, so this is actually so NVIDIA is a very famous company which focuses on manufacturing hardware suitable to run AI, like perform AI algorithms and stuff. So this is the NVIDIA RTX 4000 platform, which got released recently. And so after this platform, NVIDIA has this NVIDIA Jetson platform, which is mainly made for performing AI at the edge. So it's a single board computer platform which consists of different modules to compute AI processing. And even you can go even smaller, like the microcontroller unit platforms, like the bioterminal, and also even further smaller, such as the Grove Vision AI module. So when we want to perform like AI kind of like an AI vision task, you cannot run the same AI model which you run on this small device, because it will not process. The performance will be less, and it will have less accuracy. But with the advancement of AI algorithms and software engineering technologies, these days these small form factor devices have optimized models, optimized AI models to run on these devices. So, however, in this talk, I will mainly focus on the NVIDIA Jetson platform, this platform. So that is where we will run this no-code Edge AI Vision tool. So this is the main software architecture that we will that is used. So mainly the NVIDIA Jetson Linux boot support will be at the base with all these components, and on top of it, Docker is installed. So inside Docker, there will be 3 containers running. So that is the Node-RED Docker container, and another Docker container to grab the input video stream, and another Docker container to perform the object detection itself. So why do we run Docker here? So actually, it's easy to run all these components as Docker containers, because the inside a single host operating system, once you install Docker, if each and every application can be run as a isolated container. So they are isolated and they are very lightweight to use. So compared with virtual machines that we all know, so in a virtual machine, if you want to run separate applications like this, you need to have separate guest operating systems, and they will consume a lot of resources. So by running all these applications as Docker containers, you can guarantee that you can have a better performance, and also it's very easy to migrate this application to another device. So for example, once this solution is done on the Jetson device, so you can easily transfer to another Jetson device by just transferring the Docker containers itself to that device. So so this is the Docker Hub. So Docker Hub is the place where you find all the Docker containers, uh, all the public Docker containers. So when we look at the Node-RED Docker container, we can see that there are more than 100 million pulls for the Node-RED Docker container. So from this, we can see that Node-RED is a very famous Docker container, and a lot of developers are moving on to using Node-RED on the Docker. Because as I mentioned before here, because of these reasons, people tend to use Node-RED as Docker when building solutions. So this is the main hardware setup that is used for this specific tool that we are running. So this is the Seed Studio Recomputer Jetson. This is NVIDIA Jetson powered device, and it's powered and it's also connected to the Ethernet and Wi-Fi to provide the internet connectivity. Also, you can connect a USB webcam to this device, or else you can have the video stream sent to this device via the internet. So there's a protocol called RTSP protocol. So using that protocol, you can send the IP camera video stream to this Jetson device, so that we can later on perform the object detection itself. So if you want to learn more about the Jetson devices, the Jetson powered devices that are offered by Seed Studio, you can visit this URL and learn more about all the NVIDIA Jetson powered devices offered by us. So I also want to mention that we are an official partner of the NVIDIA Jetson ecosystem for Edge AI. So so this is so now I will go through the actual tool that I just mentioned. So this is a tool that we developed. So this is the source code for the tool. So this is available publicly. If you want to access it, you can visit this GitHub URL, or you can scan this QR code to access it. So once you go into this, you can look through the README, and you can see how it can be installed on the Jetson device. So if you also have a NVIDIA Jetson Nano device with you, it doesn't have to be actually this particular device from Seed Studio. It can be either a device from NVIDIA itself, the NVIDIA Jetson Nano Developer Kit. Even you can use that to install this tool. So so if you go through the README, you can clearly see how this tool can be installed. So you just 2 lines. So you just need to clone this GitHub repo, and then run this script. So we have this special script so that the installation process is made easier. So you can simply after running this, it will take care of installing all the dependencies and everything that is needed for this tool to run. So as you can see, it's just 2 lines for installation. And after that, so before that, I also want to mention this. So this is actually the Docker compose file. So as I mentioned before, here the 3 Docker containers, this Node-RED and these 3 Docker containers are defined in this Docker compose file. So this is the Node-RED Docker container itself, and this is the input video stream, and this is the Docker container responsible to do the object detection. So this file, this Docker compose file, will take care of downloading all these Docker containers and setting up the Docker environment. So once you run this script, so actually I have this device now all up and running. So I have already SSH into this device, and if we check Docker PS, we can see that the 3 Docker containers are running. This is the Node-RED container, the video stream, and the detection container. So if we open the web browser, and then if you look at this IP address, so if I type, so we are going to open the Node-RED flow editor. So 195, and if I go to the port 1880, so now we have the Node-RED flow editor running, and as you can see, there are 3 blocks here. So these are the 3 blocks that are defined by this by this GitHub repo. After initializing everything and installing everything, it will show you this. Sorry, it will okay, show you this one. And then so this is the tool itself, right? So this is the tool itself. So once this tool, so this tool is ready to go tool. So you simply need to drag this block. So this is the input video block, and this is the video wave block. And if you double click on this input video block, we can see that under the device type, there are 2 options. So the first option is local camera, which means the webcam that I mentioned before. You can simply connect a webcam to USB webcam to the Jetson device, and then use that for the to grab the input video stream. Or else you can use this RTSP, that is if you want to grab the video stream via an IP camera through the RTSP protocol. So you simply need to enter the RTSP URL on this box and click done. I will just go through deploying these blocks, and this is the video weave. So this is the raw video output coming in from this video stream. And then this is the detection block. So that this block is responsible to do the object detection itself. And I will drag and drop another block over here that is to video wave block. And then I will just connect these blocks together. So we can see that this video input block and this object detection block are running as Docker containers, as I mentioned before. So after you deploy this, and when you click deploy, so I will show you a video how it looks like after you deploy it. So after finishing this, and you can see that this is the input video stream from the webcam or the IP camera, right? So after obtaining the video stream, this object detection block will handle all the detection work. So I will play this video, and now we can see for all these elephants being detected in this video with confidence score. So these are the confidence score. So it's confident that it's 88%. It's confident that it's an elephant. So this is the solution. And as you can see, it's very easy to deploy this. Sorry. And also, I want to mention that if you go to this URL, this particular URL, and we have actually we have this program where if you want to contribute to this GitHub repo and maybe further add more features to this tool itself, you can visit over here and submit your PRs. And if we approve your PRs, we will gift you with store coupons and samples. So you can keep in mind about this. So also for that demo that I just mentioned, for this demo, under the hood, we run the Ultralytics YOLO V5 object detection algorithm. So that is responsible to perform the real-time object detection on the video stream. So that is YOLO V5. And also out of the box, the AI model, which is trained on a COCO dataset. So if you go to this particular URL, you can learn more about this data set. So this data set is able to identify more than 80 different classes. So this elephant is one of the the classes that particular data set can identify. So if you want to train your own AI model, and if you want to deploy your own AI solution with this tool, you can easily change the AI model to detect anything that you want this tool to detect. So I will now briefly go through some of the application ideas that we can implement using this tool. So this is one idea. So using this tool, we can identify wildfires. So we can alert systems when wildfires are detected. And also this is another example where healthy apples and defective apples can be detected. And here's another example where you can you can count the number of items in a retail store shelf like this. So that's about it about on my talk. So if you have any more questions about maybe this tool, or maybe like Seed Studio products, you can visit these channels. We have an email channel, we have Discord channels, and also we have the forum support. So you can scan this QR code as well if you want to enter our Discord chat. So that's about it about my talk. So if you want to experience this no code AI vision, edge AI vision tool that I just talked about in this so you can experience that if you have the NVIDIA Jetson platform. You can easily install on your platform, on the NVIDIA Jetson platform, and then you can run the tool and experience. And if you have more application ideas, you can implement those ideas as well, and go for more solutions. So thank you all for listening to my talk.
Cool. Thank you very much, Lakshantha. That's awesome. Cool. So I think maybe I missed it because I was doing other things. The Jetson platform is it's a small embedded computer. So that's your models only run on the Jet. Is that their own CPU? Their own ARM CPU to be like a Pi?
Yeah. So actually, it's based on the ARM architecture. And this specific tool is optimized to run on the Jetson platform itself. So because that's why it's mainly focusing on the edge AI application, right?
And so is Jetson Jetson is like a chip basically, or it's a platform. So is it available in like multiple different hardware modules? There are different vendors of Jetson out there, or is it an appliance you buy directly from NVIDIA?
Oh, actually, NVIDIA themselves provide a developer kit called the NVIDIA Jetson Nano Developer Kit. So that is a small board like this. I can show you. So this is this one.
Okay, yeah.
So this is the NVIDIA Jetson. So it's running now. So this is the NVIDIA Jetson Nano Developer Kit, right? So this is provided by NVIDIA.
Okay, cool. And then other sort of it's like a reference design, and other companies can then build that silicon into
like
whatever.
Seed Studio, we manufacture these carrier boards, right? This is the carrier board, and this is the module itself. Yeah. So this
Right, yep.
module is made by NVIDIA, this particular
Okay.
module.
Okay. Yeah. And
And
then the breakout board. Yeah.
right. So the breakout boards are manufactured. Some like manufacturers manufacture the breakout boards so that we can put the NVIDIA official system on module on top of the Curry board. Yeah.
And then with whatever sensors.
Yeah.
Cool. Okay, we've got a question from Akash. How do I integrate different AI models into the node? Yeah. So you showed us like the elephants,
sure.
but what if I want
Yes.
to detect dogs?
Okay. Sure. That's a good question. So if you, I will put back the screen.
Yeah, sure. You might just
to show you that.
present.
If you go to this, okay. So actually, that was one of the questions that was asked before in the issues. So if you go to the issues over here on GitHub, so one of the issue was like, where should the train model be placed? So this question is already asked over here. And if you follow this, these steps, you can implement your own AI model into this solution. Just follow
you build
this
the model
issue.
with is that with something? I'm just reading. Trying to read
Actually, this model is first trained on YOLO v5 using YOLO v5. So
okay,
YOLO
yes,
v5
you said the YOLO v5.
is
So,
the
so it takes a YOLO
object
v5
detection
model into the
yes,
system.
exactly.
And then,
So what we do is we input the train YOLO v5 model into this source code, and then we run it. Yeah.
Cool.
Yeah.
Okay. Yep. Thanks. Akash said thank you.
problem.
Brilliant. Awesome. Cool. Okay. I don't know if there's any more. So a quick scan up. That was just Akash liked the presentation. Seeing if there's any more. We have to wait for the stream to catch up.
Okay. So it's
and then
syncing with
in case
YouTube,
there's
right?
anything else. Yeah. So obviously I asked for those questions, and then it takes about I think we're about 45 seconds to a minute behind probably on YouTube. So by the time that comes back, it doesn't look like we've got any more questions. So we shall leave it there. Okay. Well, thank you very much. Enjoy the rest of your day or what's left of it.
Thank you very much.
Thanks, Akash. Bye.